Hello, good evening to all of you. Um, Welcome back to the course on Statistical Computation Laboratory. Uh, Last week we completed experiment on regression analysis and modeling in our environment, right? So what is regression analysis? What are the types of regression analysis, right? We completed lab on simple linear regression, multiple linear regression, and then logistic regression, and even multi-class regression. Okay, with respect to machine learning, there are two problems: regression problem, wherein we predict a numerical value, and in case of classification problem, we predict the class. Okay, whether yes or no, or whether student will be admitted or reject, or patient is normal or have some kind of a disease. So, or there can be a species of flower. So wherein we say this belong to this particular class one, or this belong to second class two or class three, something like that. So is this clear to everyone? Classification, uh, Advait?
Yes, sir.
Yeah, classification and regression clear.
Yes, sir.
Okay. Okay. So my uh, Google Classroom page is visible to all of you. Advait,
Yes, sir. It is visible.
visible. Okay. So you have to go to classwork, and now your batch is B, and you can see in the batch B. Today we are going to perform again regression analysis and modeling using Python environment. And there are four parts to be completed in within 2 hours. Part A, simple linear regression analysis and modeling. Part B, again multiple linear regression analysis. And part C is logistic regression. And part D is a multi-class logistic regression. Okay, so I hope you are now completely familiar with this types of regression analysis and logistic and multi-class logistic regression. Soham, Chautalia, Soham.
Yes, sir.
Yeah, it's clear with all these types of
Yes, sir.
regression. Okay. Can you briefly explain us what is regression
Yes,
analysis, concept
yes,
of
sir.
regression?
Yeah, sir. So in regression analysis, we basically predict
Okay.
uh, based on some mathematical
Uh,
logic. Means in simple linear regression, we use the line equation y equals to mx
okay.
plus c,
What is y here?
and in logist.
Yeah, what is
Yes,
y here?
yes, sir.
Y is a response variable, and x is a predictor variable.
Yes, sir.
Okay.
Independent.
So
Yes,
yeah.
yes,
So regression is statistical tool to establish the relationship between the variables. Okay, in which one of the variable is a response
yes.
variable and it's always one.
Mm,
Response variable is always one. Okay, whereas
yes,
the predictor variables, there can be one or more than one. If it is one predictor variable, then it's simple linear regression. If your predictor variable is two, then is a then it's a multiple linear regression. Correct. If it is a categorical variable, yes, no, then it's a case of logistic regression.
yes, sir.
If there are two cases only, binary. Okay. If it is more than two,
Yes,
your response. I'm talking about response variable. If it is y is a
yes,
response. If it is a continuous, then it's a regression. And if it is a response is a uh, if it is two types of response, either one or zero, then it's a binary. If it is more than that, then it's a multiple logistic regression. Okay, but with respect to independent variable, if it is single independent variable, then it's a simple linear regression. If it is more than 2, it's a multiple. Clear? So I think now you are completely aware of all these 4 types of regression, and you perform the lab, and hopefully each one of you have submitted uh, the lab on Google Classroom. Okay, thank you, Soham. So now you have to tell me among these 4, any 2 I'll be demonstrating you, and 2 will be given for do it yourself mode. Okay, so we have 17 number of students. You just tell me out of these 4, which 2 I should demonstrate to you. Choice is yours.
So can you demonstrate the last two because they were a little bit over the head?
Okay, logistic regression and multiple logistic regression, right?
Yes, sir.
Yeah, okay. Each one of you are agreed? Advait, Soham, Mritin, Jay.
Multi-class.
Uh,
Multi-class logistic.
which one? Sorry, Ankit.
Multi-class.
Okay, fine, fine. So I think multi-class we did not cover in the sense in R as well, because it was given to you to perform yourself. So that's okay. I will start with the multi-class regression analysis. Is that fine to all of you? Majority of students saying, shall I go to the last demo?
Yes, sir.
And then you can, Sharvari, what do you say? Sharvari,
Yes, sir.
shall I go to
Yes,
the
sir.
last one? Logistic regression,
Yes,
multiple
sir.
logistic regression. Okay, fine. So I hope now this screen is visible to all of you. Okay. And let's go to the Google search engine. Let's do step by step and just search for Google Colab. Okay, Google Colab, and okay, and open a new notebook, Jupyter notebook in Google Colabs. So it will take time because it's laying out a notebook for me. Yeah. Uh, yes. So now my notebook is ready. So let me start the cloud instance. And before it starts, let me name this lab. So this is lab number 4, regression analysis and modeling. Okay. And your batch is B, and we are doing uh, B, part B. That is a multi-class linear regression, logistic regression. Okay. Well, so let's do it step by step. So step number 1 is import important libraries. So import the libraries in a Python. So this is a Python environment. So we require a pandas, which is a data frame library, pandas SPD dot name. Then import numpy or numerical calculation and matrix computation. That's a numpy numerical pi Python, and that as a NP. And this numerical NP, that is numerical pi, numpy, it is based on scipy. So I need to call even SP. That is, so I'm giving a short name to call them by name SP. Okay, so SP stands for scipy, scientific Python. And then in order to plot, we require uh, one of the matplot pyplot as a PLT. So I'm calling them by short name. And we require one more. We may use one more graphical library, that is Seaborn. Okay, Seaborn as a SNS. So this, so import the libraries. Done. Let's go to the step number 2. Now you have to upload some data sets. So next step is import the data set. Okay, so I will import data set. So you go to uh, the and upload the data set. So I have data set. Let's say iris data set. Where is iris data set? Yeah, this is iris data set. I'll be uploading the iris data set. Okay. So this is the iris data set. I want to import it. Okay. So how to import the data set? So in Python, there is a pandas library for data frame and read underscore CSV, and your name of file is iris data.csv. I think data.csv. That's the name of, okay, and store this as a frame, data frame, df. Okay, and let me show you that df.head. So next is review the data set. Review the data set. This is iris data set, class species data set. So let me review that data set. So it's loaded as a, imported as a data frame. Let me show the first 6 observations. So you can see this data set, uh, you know, consists of these sepal length, sepal width, petal length, and petal width, and the class. So it's a labeled data set, but column names are not given. So if you look at this, column names are not given. So before that, I just want to, okay, just a minute, okay, and this data set, iris data set. So yeah. So this data set, is this figure is visible to you? Terwari? Hello?
Yes, sir.
Yeah. So this data set is iris data set, consists of the uh, 3 species of flower, and they are Setosa, versicolor, and virginica. And there are total 101 to 150 observation, each of them 50. So 50 into 3, there are 150. Okay. So, but then right now, then if you look, when I imported that data set as a data frame in a pandas, and I displayed in front of you, there are no column names. So what I would suggest you, the next part is data preparation. So let's say data preparation. Okay. So data preparation, we have to create some names. So I just want to give some names. So I'm creating a list. So first is sepal length. Okay, let me see. First is sepal length, sepal width, petal length, and petal. So sepal length, obviously I think GHT. Okay, and its value is in cm, in centimeter. And next is sepal um, width is also in centimeter. Third is petal length. So these are one minute, just either you can use single quote or double quote. Okay. Petal length, and again that is in centimeter. And petal width, that is also in centimeter. And the last is your class. It's a class label. So I'm writing last column is the class. Okay. So these are the column names. So I'm just creating the list. You can see this bracket, square bracket means list in a Python. And then I will read it read this data set with names equal to names. Okay, the names equal to, okay, by default is none. So, but I have now names equal to names. It's okay. It's type names equal to names. Yeah. Now it is. So what you suppose to do it? First, you create a list looking at the data set. Okay, column name, first column, second column, third column, fourth column, fifth column. So sepal length, sepal width, petal length, petal width, and the class. And then you import the data set and assign column names by that created list. Names is equal to that created list. Up to this point is clear. One of you give me the confirmation. Hello.
Yes, sir.
Okay. So now let me reread it again. So let me review the data set. So now it should give me the yeah. So you can see sepal length, sepal width, petal length, and petal width, and the last is column. I think I made a mistake somewhere. Okay. Okay. Centimeter. Okay. Read it. Is it visible? The font size is visible to you, right? Sharvari, font size is visible?
Yes, sir.
Okay. So let me reread it again. And now, yeah. So first 5 observations, numbers start from 0. So that is 0 to 4 means 5 observation. Okay. So this is about. So next is see the dimension. So check the dimension of the data set. So next step is check the dimension of the given data set. Given data set. Okay, so how to do that? So df is the name of the frame. Df dot shape. Shape gives you total data. So total there are 150 observations and the 5 attributes. So you can see in this diagram what are these 5 attributes. Means sepal length, sepal width, petal length, and label is your class. Clear? So total 5. Next is even you can check the what are the column names. So check the column names as well. Because in case sometimes there are hundreds of columns, so check the column names. Also important. Right now only 5 columns, but it's a make a habit of checking the column names as well. So you can see over here the column names are sepal length, sepal width, petal width, and the class. One more thing is you can even check the from data pre-processing point of view. Okay, pre-processing. Sometimes we need to understand the the data types. Okay, so that is required. Sometimes we need to convert into some format. So this step is a data transformation. So I can say here as a part of data preparation, data transformation. So we'll discuss this maybe later, but today, so make a habit to check. So D types. So command is D types. So you can see data D type. So your sepal length, sepal width, petal, these are float, and the class is object. It's a categorical variable, and that you can check it. Okay, in this is iris setosa, and this. Okay, and versicolor and virginica. So these are 3. Uh, so I hope up to this point is clear. Next is just analyze, and let's do some kind of statistical analysis. So statistical analysis in the sense, how to do the statistical analysis? We have not describe. So describe, okay, and so statistical analysis using describe function. So parenthesis. Look at this. So it's a describe function. So data frame describe. So you can see there are total 150 count of each column, and mean value of sepal length is 5.84 something. The max value. So max minus mean gives you a range. Standard deviation, mean value. Sorry, I made a mistake. Mean and mean, minimum and average value. So max minus mean gives you the range. So you can see the distribution of this data set of each type. Okay, so you can use simple command df.describe. Okay, so it gives you simple statistical analysis where you can see the count, mean value, that is average, standard deviation, mean, minimum, first quarter, three-fourth quarter, and the maximum. Okay, for each of them. Correct? Or you can even df.hist, you can give the histogram of all of them. So if you want to see how each is distributed. So using df.histogram. So this is histogramming. You can check. You can use graphical analysis. Uh, analysis as well. So okay, here. So you can see the petal length. Uh, uh, Petal length and petal width, sepal length and sepal width. Okay, or even sometimes we need to supposedly I want to draw a plot. Okay, so df dot let's say plot. Sometimes we see scatter. Let me see scatter. X is there. No, it's not there. So this scatter matrix is not defined here. So you can use other dot scatter. Yeah, dot scatter, and you can pass the data frame. Okay, so it is asking give me in terms of x and y. So df dot let's say sepal length 1 minute. So what? So let before that we can even understand the concept. So concept of understand concept of series, right? Okay, concept of series, which is equivalent to in R is a vector. Okay, so supposedly I want to access a particular column. So df dot sepal length, sepal cm. Let me see the sepal length. Okay, capital. Okay, so it's right. Yeah, yeah. So you can call by this way also. Yeah, it's sepal. Yeah, so you can see you can call by uh, this way also that particular column. So this I can. So this means you are converting to series also. Okay, this I can call it is a series. Say let's say this is x. Okay, pd panda dot series. Yeah. So this way, okay. So let's say,
So,
yes.
so it should be LENGHT because you have named
I
it
made a
like that.
mistake in spelling. One
Yeah,
minute.
so it should be.
I'll 1 minute. 1 minute. I think I maybe LENGHT. Yeah, that's a mistake. GTH. And Okay, 1 minute. So it was showing here. No, I think I just did it here. Okay, just 1 minute. Give me this minute. Okay, DF double quote sepal should come automatically once it is loaded. Sorry. So what you can do is, rather than see while typing there is a mistake. So what you can do, very simple thing. What always you practice BF dot columns, right? Columns. So whatever names are there, you can just copy from there, okay, and then make use of them while listing it. Is this clear? Hello, Sharvari?
Yes, sir.
Yeah. So rather than there is a possibility while you typing there is a mistake. So run this command, this df dot columns, okay, and from there just copy that name of that, and you'll get a series. So you are converting that in a series. So you can see it is just showing the first column only. So similarly, I can check each one of them. It's like a series kind of thing. Is this clear? Okay. Now supposedly I want to do a plotted a scatter plot. Okay, and this is BF. Again, we'll have the sepal length. I'll just paste it here. Sepal length and BF. Sepal width. You can see, able to see the scatter between these two variables, sepal length and sepal width. Is this clear? So you can use a graphical analysis as well. Up to this point is clear? Hello? Up to this point
Yes,
is
sir.
clear? Okay. Otherwise, there is lots of options available. Anyway, we will take up this data visualization sometime other. I think I use this also. Box, you can have even box plot, okay, of your data frame. Okay, with let's say there are subplots. Okay, subplots equal to true. Okay, and uh, there are total sepal length, sepal width, and petal length, petal width. So there are total 4. So we can have layout of 2 by 2, because there are, I want to because each row will have 2 plots, and just plot it. Subplots. Subplots. 1 minute. P. So P is missing. Subplots. You can even plot also. So you can see their box plot as well. Clear? So there are a lot of options available. We will explore in data visualization part. Okay. So you can have just graphical analysis of these. Okay. So we started with this. So now next part is up to this point is clear. One of you give me the confirmation. Mrityunjay.
Yes, sir.
Okay. So now next is, let's say let's have some analyze. So what is our objective? So let me write first my objective. My objective is what is your objective? 1 minute. See, objective is to classify the flower species, classify the iris flower species. Okay, it's iris flower species. Okay, so there are 3 classes. Okay, for given x, and x is a given x. What is x? Is a multi-dimension. So x is always multi-dimension. Okay, x is always multi-dimension. What is that x is? X is nothing but your sepal length. Okay, sepal width. These are features, right? And petal length and petal width. So these are 4 attributes are given. So x is multi-dimension means x is features. So these are the 4 features. So x is always multi-dimension. So what is our regression analysis? Nothing but y is a function of x, and I'm writing capital X. Why I'm writing capital X? Because x is a multi-dimension. Okay, so here I'll write for given sepal length, sepal width, we are supposed to find out from this feature what is the class of that flower species. Is this clear? So this is our objective. Okay, so you can see in this picture also, from given sepal length, sepal width, petal length, petal width, you have to classify that flower. Let's suppose I give you 6.4 and a 3 sepal length, a width, and 1.4 petal length and 1.2 petal width. What is the name? What is the class of that flower? Okay, so that's what our objective is. So it's a multi-class because it's more than 2. There are 3 classes. That's why it's a multi-class. So let's go to the next part. So next part, this is our objective. So next part is, let's have some analyze this class. Okay, let's say analyze the class distribution. Is there is a data set class imbalance or not? So analyze the class distribution. So there are 3 species given to you in this data set. So let's analyze that class distribution. Okay, so how to do that? So first, again, practice the columns. Take the first name of the column. So last column name is a class and capital C. So what I'll do, df group by is a function. So df group by is a function, and I'm going to pass as a last the class, and I'm going to write size of this. I want to know what is the size of this class. So there are total 150 observation, and you can see here iris data set, iris setosa 50, versicolor 50, and virginica 50. So there is no class imbalance. Each of them 50, 50, 50. Okay. Up to this point is clear, Ninad?
Yes, sir.
Yes. Okay. Thank you. So now we got to know this is a way to figure out what is that class is. Now next step is we're going to use. So next part is data partitioning. So we're going to build a model. Okay. So for that, we're going to partition the data. Data partitioning, data partition, 80% for train, so that we can build a model on this, and 20% out of 150, we are going to use a test to validate for validation purpose.
लेक्चर घेतात
Yes.
एका ना मला नवीन फुटबॉल शूज पाहिजे होते
Tomorrow we'll discuss.
काय
Tomorrow we will discuss.
ऑर्डर
Tomorrow we'll discuss.
काय डिस्कस काय
Sorry. Okay. So data. So 80% we're going to use as a train the model. So based on that, we're going to build the model, and then 20% hold out. Nothing but that is unseen data by the model, used for the validation purpose. Okay. So how to do that? So there is a one important library which is open source machine learning library, scikit-learn. Okay. So scikit-learn, and there is a model selection. So from scikit-learn model selection, you have to import train split function. Okay, this library, train sub library of model selection of scikit-learn. So you have to import that library. Okay, and then we are going to divide. So your x is a sepal length, sepal width, petal length, and petal. So x is we are splitting into two. So your x is your multi-dimension data features. Okay, so that you are splitting into two parts, into two, train and test. Okay, so the x is a feature. So I'll write here, x is nothing but features, attributes. So that x is we are going to divide into two parts, x train, correct, and y x train and the x test. So we are dividing into two parts. Similarly, we are x train, for that there is a y train. So for y train, y is a label, right? Y is a response variable, right? Remember this, y is a function of x. But x is our features and y is a response. So whatever train data with respect to the train labels, so that's a y train, and y test, these are the labels of the test. Are you understanding? X train, x test, and y train, y test. Aditya, Arsora, Aditya.
Yes, sir.
So are you understanding there are four parts?
Yes, sir.
X train,
Yes, sir.
x test, y train, y test. Yeah, what is x
Yes,
train?
sir.
What is x
So-
train?
So I'm not following the link. I
Okay.
lost the connection in between. Sorry, sir. I need to
Okay.
get back to you.
Okay, fine. Aishwarya?
Hello,
Jadhav.
sir. Can you hear me?
Did you understand x train, x test, y train, y test?
No, sir. I have doubts in this. So I was like waiting for
Okay.
you to write the next command. So I was waiting.
Oh, no. I'm going to write a next command, but you have to understand what is this, these four parts.
All right.
See, okay, I'll repeat again.
Sure, sir.
Okay, I'll repeat again. 1 minute. Give me. See, look at this data set. This data set consists of sepal length, sepal width, petal length, and petal. These are the features, right? These are attributes. 1, 2, 3, 4. And class label is also provided to you. See, it's a label data set. So let's suppose first observation, 5.1 sepal length, 3.5 sepal width, 1.4 and 0.2. Okay, petal length and petal width correspondingly. So, respectively, that's related to setosa. So what are you doing? This entire data set, which consists of 150 observation, we are dividing to, this is X, this is capital X. and this is small y. Aishwarya, are you following me?
Sir,
And all
I'm
of you?
getting it, bro.
Yeah. This is your capital X up to sepal length to petal length. This is your capital X multi-dimension. 1, 2, 3, 4. And this is your Y.
Okay.
Yeah.
Yeah.
Clear?
Yeah.
Correct?
Understood. Yeah.
Understood? Fine.
Mm-hmm.
And this you are divided into two part, train and test. So X will be divided to part now, X train and X test. Similarly, Y train and Y test.
Okay, so we're basically dividing it into two different columns of the X and the Y, right? One is for
Yeah,
train data and the other is the test data.
rows.
Okay. Yeah,
One row
rows.
means all these columns.
Yeah.
Yeah. So we are dividing into rows.
Okay.
80% rows randomly we are going to choose for as a train the model, right?
Okay.
And 20% we're going to choose for a testing the model. So you are splitting it into two parts. So while you splitting X is X test and X train and X test, you're splitting same time labels also, right? That is a Y test and Y train and Y label. So there are going to be four parts. So this is your capital X, okay, and this is small y. X is split into two: X train, X test, Y train, Y test. Clear?
Yeah.
Yeah. Thank you. So let me go to this and let me now partition this data set. So there are four parts. Hopefully now it's clear to you. So for that, how to split it? We are using a library train underscore test split. Okay. So what is outcome of that splitting? It will split into four parts. The data set: X test and X train and X test, Y train. So X train corresponding Y train, okay, and Y test X test corresponding is uska label, right? And then I'm using train split is a function, okay, and to which I'm going to pass what X and Y, okay. So to which I'm going to pass X and Y, correct, and I'm going to say my test size would be 0.20 means your 20%, and in order to have a set seed, in order to have a repeatable results, so I'm going to use random state equal to 0. So what is X? I have not mentioned here, so I'll first. So what is X? X is nothing but your data frame with the attributes. What are those attributes? It's a multi-dimension. That's why I'm using two bracket. Understand the significance of two bracket. So two bracket means it's a multi-dimension array. So to which I'm going to pass. So how to pass it? My suggestion to you: always use df.d types. Okay, d types. Sorry, columns. Columns. This is a command. I'll just, for a time being, I will run this. So I'll just copy this much part up to here. I'll just copy this and I'm going to write now what is my X. X is your feature attributes. So what these X are nothing but sepal length, sepal width, petal length, that's a petal width, and they are inside two double bracket. Okay. So sepal length, this. So this I'm going to, and what is Y? Y is nothing but a class. Y is equal to df dot class. This is a single variable. Yeah, I can access it single variable. But X is a multi-dimension, so I have to write in two brackets. And let's see X and Y. It's done, right? I'm just delaying this step. Understand now, look at the X shape. See, first of all, let me show step by step. If you look at the actual, the shape of the original data set is consist of 150 by 5, and now I have converted to X and Y format. So X is a feature attributes. There are 4, so it 150 by 4. And if you look at the Y shape is your 150 by 1. I1 means comma 1. So you can see 1 is not mentioned here, but it's a single variable. That is a response variable. So df dot shape is original data set consists of 150 observation and 5 attributes, but I convert into the independent variable and response variable. So x dot shape, there are 4, so it is written over here. Okay, and y shape is response is always single, so it's a y dot class. That is the last column. Up to this is clear to everyone. One of you give me the confirmation. Advait, Advait or Alvan.
Yes,
Alvan
sir. Yes.
Dimelo. Alvan Dimelo.
Yes, sir.
Clear?
I'm Advait. Yes, sir. Clear, sir.
Yeah. So this is your original
Yes,
data. Converted to two part X and Y.
Hello.
Because that is help us in understanding, right? Now this is the step I'm going to perform it. So what is going to happen? Let's see. So next step is I'm splitting the data into train data and the test data. So using train split function, and I'm going to pass x comma y. So where x is a feature vector, y is your response variable, test size 0.20, and random state so that you can have repeatable result. Underscore state equal to 0. Yeah. So clear up to this point. So it is splitting. Now look at the 80% of 150 is going to be train data set. Okay, that is on which I'm going to build a model. So train dot shape. So you'll get 120 by 4. Hello. 80% values of 150, and y the x test 20%. So that I mentioned, right? X test dot shape gives you 20% of 150, 30. Okay, by 4. And let me just show you x train. X train just first 5 observations of 5 columns. So you can see these are randomly chosen. See, I'll just compare. My friends, please understand. Understanding is very important. If you look at the original frame, there are numbers are in the ordered sequence 0, 1, 2, 3, 4. But when I displayed the first observation, 5 observation of my train, which was randomly sampled from the original data set, numbers are look at 137, 84, 27, 120. So they are random samples are taken. Are you understanding this? Similarly, let me show you even X test. X test 0 to 5. Okay, so you can see X test 0 to 5 is 114, 62, 33, 10. So these are random samples are taken. Okay, but there are 30 here and 120 in X train. Okay, so I hope Ankit Datta is clear up to this point. How did I split the data into 2, train data and test data?
Yes,
What is the
sir.
meaning of X train, X test, Y train, Y test?
Yes.
And what is the concept of random sampling?
Okay, sir.
Hmm.
So train data is used for building the model.
Yes.
We take 80% of it,
Okay.
of the data,
Hmm.
and test is for testing the model for
Yes.
future purpose. It's
Yes. For
20% of the
validation
data.
purpose.
Yeah, validation.
Yes.
X is over here we used it for different parameters like sepal length, sepal width,
Sepal width.
petal, all those 4 that you have
Yeah.
mentioned.
Correct.
It is multidimensional.
Okay.
While Y is the class.
Yeah, single. It's a single
Single.
response variable.
Yes, we use the
Yeah.
split function,
Yes.
train underscore test split, to
Yeah.
split the data in 80 and 20, and then we displayed it out there.
Correct. Okay. So now let's start building the model. So now data is splitted. So next part is to build the logistic regression. logistic. It's a multi-class, obviously, logistic regression. But here what we call is a classification, because it is not we are not predicting a value, rather we are predicting a species. Okay, so it's a classification. So again, we are using machine learning library. Scikit-learn is open source library, very widely used in machine learning. So scikit-learn, okay, dot linear uh, linear model. The sub-library is import logistic regression. So to import that library, okay, and then you have to build a model. So next step is build a model. So I'm giving some name, let's say log mod, and logistic regression. So to create an object, that is an algorithm. Logistic regression is algorithm. Okay. So what we are doing, we are mapping x to y. What is the meaning of it? X are a feature vectors. We are mapping to the y with the help of algorithm. That is logistic regression. So this becomes a model. Okay. So x to y are mapping using learning algorithm. So here is learning algorithm with logistic regression. So with this, you are also understanding what are the learning components. What are the learning components? Harsh Dungarani.
So the expartum, sepal width, sepal length, petal length, and petal width.
Yeah, that means data set.
Yes, sir.
Yeah. So it's nothing but data learning. But
Yes,
how
sir.
does it learn? It learns with the algorithm, no?
Yes, sir.
Yeah.
Mapping,
So
sir,
learning
from A to
components are
B.
X and Y and the learning algorithm. Okay. So essentially it's nothing but data learning. So it learns from the data. Okay. So model is built. Model is the object is created. Logistic regression, that's algorithm. Okay, which help us in learning that attributes. Okay. So next part is a train. So train the model. Means this is a learning phase. Train nothing but your learning phase. It learn from the this is learning phase. Okay. So how to do that? So we have created name of that model log mod dot fit. Now you tell me what are you going to pass? Harsh Dungarani.
Yes, sir.
Now fit is a function used for training the model.
Sir, X train and Y train.
Correct. So X train, this is a and corresponding labels of that train data. So we are passing both attributes and the label. Yeah, done. Okay, I would suggest you to use even we are interested to know the training time and testing time. So time calculation also important. So you can use time function and so you can use a time function. So percentage time and run it. Yeah, you can see here it took 38 milliseconds to train that model. So my model is ready. Hello, my model is ready. So model is ready, right? So next part is a prediction, model prediction. So model is ready. So now this model is capable to predict. Model prediction. Okay, so what to do? That model name, what is that? Log mod is a name, and the predict is a function. So remember, fit function is to train the model, and uh, uh, predict function is to predict. Now, one of you, uh, Jay Dalvi. Now to Jay Dalvi. Jay Dalvi.
Yes,
Okay,
sir.
Jay Kale. Jay. So now I'm going to predict.
Yes, sir.
So what I'm going to pass to this function?
Yes, sir.
Yeah, tell me.
X test and Y test.
What?
Hello.
We divided data
X
set into
test
two
and Y
parts.
test.
and it is going to predict. White test is actually actual labels, right? Hello. Okay.
Yeah.
So before I
Okay.
predict, okay.
Hmm.
Yeah, clear. Okay. I think before I predict, let me go to the next step and then come back to the this step. See, when I see white test is nothing but your label.
Yes, sir.
Yeah. So there are 30 observations. So if you look at this white test, these are a mixture of it. So Virginica, versicolor set. Okay, I will do one thing. I'll just show you few of them. 0 to 5. See, I'm just first 114 Virginica. Okay, versicolor, setosa, virgin. These are the first 5. So these are actual one, right? White tests are
Yes,
actual
sir.
one. These are actuals. Now model is going to predict from the X test. Okay, just a minute, my friend. Just concentrate on this. If I give you Y0, means first element. One minute. Yeah, one. Yeah, I'm just passing. Yeah, this is where you need to pass. Okay, so the first is your Virginica, 114th, 114th observation is Virginica, and predict. I'm going to pass the X test. Okay, X test. Yeah, and it will predict. So that predicted, I'm going to store as a Y pred. So it will pred for 30 observations. So you can see over here what are the predictions. You can say read. So you'll get all those 30 observations. Okay, and if I show you the first one, 0, it's an array, the Virginica, and really 141st observation itself is Virginica, right? Is it correctly detected? Hello.
Yes, sir.
Yeah, it's correctly detected. We are just verifying it. Okay, but how to evaluate? So next part is how to evaluate multi-class logistic regression or classification.
So can you repeat?
How to evaluate the model? Generally, how do you evaluate the classification models? We covered last lecture, last lab. Confusion matrix. True positive, true negative. False positive, false
Yeah.
negative.
Yes, sir. Remember.
Remember? Okay,
Yes, sir.
if you are not recollecting, then I need to show you that diagram to you. Confusion matrix. Do you remember this?
Yes, sir. True positive,
Yeah.
true negative.
True positive, true negative. These are correct cases, correct detection. And misclassification, false positive, false negative. So that's a model evaluation. Yeah. So now model has predicted, but how do I check the performance of model? So there are the performance metrics. So there are some performance metrics, okay, that we supposed to use to evaluate that model. Clear? So quick is yeah. So from scikit-learn is a very useful and very widely used library. Please remember, there is a metrics sub library. We import confusion. Sorry, confusion. Yeah, matrix, and then pass to the confusion matrix the y predicted. That's what we predicted, right? And the y actual.
Yes, sir.
And then it gives you confusion matrix. Yeah. Find the now. What is accuracy here?
So, but so this is 3-dimensional. So
Why?
Like
Because why
true
three
positive,
dimensional?
true negative,
Because three classes, na, Setosa, versicolor, and Virginica.
3 classes. Okay.
It's a multi-class,
Yes,
na,
sir.
my friend. It's a multi-class classification, na. There are three classes: Setosa flower,
Yeah.
versicolor, and sorry, versicolor, and I think Virginica, right? These are the three types.
Yes,
That's
sir.
why. So, Setosa, okay, then versicolor and Virginica, and these are predicted. So you can see, well, they said first is Setosa, 00 year, and 00 year means correctly detected. There's no, so 11 plus 13 plus 6, how much it is?
30.
30 divided by total
30.
is again 30. 100%. Score is 100%. Okay. So one more method is to find the score is a log mod. That's a model log name of that. There's one more function. Please remember. Okay. To which I'm going to pass the y predict, pred and the y test, and it will find out. Oh, sorry. Sorry. I made a mistake. It will have to find send a x test. It will calculate the y pred, and it will compare the actual and gives you the efficiency. It's a one. It's a score that is an accuracy 100%.
Yes,
And
sir.
you can check it out. It's 100%. See, when we pass to this another function score. So far, friend, don't confuse. Fit function is used for what purpose?
Training purpose.
Okay. Predict function is used. What purpose?
Means to output, predict.
Predict. And then score function is used for what purpose? To find the accuracy. Directly.
Accuracy, yeah.
Yeah. Clear?
Yes, sir.
Yes. Now what you're supposed to do is, one more thing is, I need to forgot to mention. 1 minute. Give me just a minute, and then you can start your part. Where I did y prediction. I just want to find out even prediction time. Prediction time. How much time it take for prediction? So it just take 2.1 millisecond for prediction purpose, whereas for training it takes around 38 millisecond total. Correct? Because there are 30 observations. So in order to predict, it just take two. So model complexity in all that, the training time and the testing time is also equally important, along with your performance metrics like accuracy, misclassification rate, okay, precision, recall, F1 measure, coherence kappa value. Along with that, even your training time and testing time, prediction time is also equally important to choose the right algorithm or right model for your data set, your case. Friends, is this clear? Okay.
Yes, sir.
Yeah. Even you can, even let me how even further we investigate. 1 minute. Further investigate the model further. Further investigate. Supposedly, if I do log mod and predict, you can see the prediction probabilities. Can you see one more function, new function I'm introducing you today? X test. I'm passing X test, and it gives me the prediction. 1 minute. I'll just store this as a YP2, Y prediction 2, and then I'll explain to you. Even in terms of probability, logistic regression is between 0 and 1, right? That I discussed last time. The S. Okay, I think that case we example taken was home price, the insurance data, whether that customer will buy the insurance or not. Okay, So if I show you y predicted 2, it's same. Okay, it's an array. So I'll just show you. First 5 value I'll just show you. See, look at this. Probability of X test. This is 10 raised to minus 4. Means setosa, with respect to setosa, 1.12 into 10 raised to minus 4 probability. This is with respect to versicolor. It's a 5.9 into 10 raised to minus 2. Means 1000. So if I take this, I'll just copy and paste it over here and divide by 1000 means 3 and 10,000. That's a probability of being a setosa. Whereas I take this 9.4 and divide by 10 raised to minus 1 means 10, na? Yeah, and this is around 94 point, sorry, let me run. This comes around 94 and this comes around 0.005. So it also calculate the probabilities. Okay, so being a setosa, it's this much probability. Being a versicolor, this is the probability, and this is. So if you see that this probability is more than far more than the versicolor and setosa, that's why it's a Virginica. Is this clear? So you have to investigate. Just don't just blindly believe in the model. Always investigate your results. I hope it is clear to everyone. One of you give me the confirmation. And okay, Maitreyi.
Yes, sir.
Maitreyi,
Yes, sir.
can you sum up today's lab?
Yes, sir. First, we studied the multi-class regression here. So we first imported the libraries. The first step was that. Second step, we imported the data set which we want to work on. In this case, it was iris.
Okay.
Then,
okay.
we
Go ahead,
did
Maitreyi.
data pre-processing to understand the data types.
Yes.
Then before building a model, we did data partitioning, 80% for train, 20% for test. When test was for validating the model. Then to build the logistic regression,
Yeah.
we built a model. We predicted a model. And
Okay.
the accuracy, we found out the accuracy of the model.
Yeah. Fine. So you are I mean understood the entire lab. What is
Yes, sir.
multi-class logistic regression? Till
Yes,
the
sir.
last part, even investigate the results of model.
Yes, sir. Understood.
Okay. Okay, so I'll just ask one more student and then you can start practicing. Thank you, Maitreyi. Sharvari.
Yes, sir.
Your take on this lab.
Uh, so first we imported all the libraries, NumPy, Pandas, SciPy, Matplotlib. Then we imported the data frame. We saw that the data frame did not have like the column names, so we did names equal to names. We
We
pre-processed
created
the
list
data.
first. We created list
Yeah,
and then we.
yeah. Names list, and then we like while importing the data frame, we wrote names equal to names. Then we did data pre-processing. Then we did data visualization, explored data analysis. We plotted histograms, scatter plot. We used SNS. Then we saw subplots. Then we imported train test split. Then we split our data set into X train, Y train, excess Y test. Then we imported the logistic regression model. We fit our data X train and X Y train on our model. We train it on that data, and then we predict it on the X test and Y test part. Then we see our predictions. Uh, then we can calculate our score using the dot score. We can also calculate probabilities using underscore proba.
Predict underscore probabilities. To just further investigate how my model is, because logistic regression based on a log odds, that is a probabilities. Okay.
Yes.
Okay. So I know I not covered mathematics behind this because I don't want to you people get bogged down by whole of mathematics. Definitely we will cover the mathematics behind this as and when required. Okay. So just I want to make you comfortable with this environment, and I'm dumping lot of information on a Google Classroom. I hopefully you are going through those links and I mean at least you are reading them. Am I right, Sharvari?
Yes, sir.
Okay. I'm actually posting a lot of material on a Google Classroom, and you people are supposed to read it. Okay. So thank you. So I'm just uploading this. 1 minute. I'll just give me. Okay. I'm just uploading this for your reference. Lab just now I perform.